all, welcome back to Sri Sai Tech Edu YouTube channel Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. I've already uploaded Module 1 and Module 2 whole modules video separately in a playlist. Now the Module 3 I've already uploaded some of the topics which is theory. In this video we are going to do the problems which are related to the previous theory. I've already done introduction, types of control systems, effects of feedback systems, modeling of mechanical system elements, electrical systems, analogous systems. Now, as I told in previous videos also, after completion of analogous system, I told I'll do problems on mechanical translation system and mechanical rotational system. Next two videos will be on that. After those two videos, I will continue with block diagrams and signal flow graph. It is of this module only, but I am doing problems in a separate video so that it will be easy for you to understand the theory first and problems in a separate video. Till here we have completed in the previous video. Now in this video we will see problems related to mechanical translational system and mechanical rotational system. In this video particularly only translational systems I am concentrating. Problems on mechanical translational system. Here if you see, this looks like a translational system. If this is a spring, this is a damper circuit and this is a mass. Okay, then how to do the sum? If you see the question, what they are asking for the mass spring dashpot. Mass spring dashpot system. This is mass, this is spring and this is dashpot system shown in figure. Obtain the transfer function. They are asking for transfer function. Also obtain the analogous electrical network based on force voltage analogy and force current analogy. See, they have given one mass spring dashpot system, nothing but translational system. They are asking for the transfer function. If you want transfer function, initially you should write the differential equations from the network or the system, and again we need to convert that to analogous electrical network based on the force voltage and force current analogy. We have studied these topics previously in theory. Now practically in problems how to do, I will explain. First, you need to write for any system, you need to write free body diagram. As we have seen in the previous videos also, in the theory part, I have shown how to write the free body diagram from the system. We will see how to write the free body diagram. First, you will draw the mass element and you can see the force is applying towards the mass in this way. So, we will write the same. But the other elements, force you need to apply in the opposite way. So K is the spring. So you are going to write Kx. Why? Because the displacement is given as x, Kx. And for damper circuit you will write F. Either you can write FF, but in question it is given F. Okay. If it is given B, then you should write FB. Okay. As it is given as F, you will write FF. Okay. So after writing that, we know that in translational system we will consider force is equals to mass into acceleration, Newton's law of motion. Force into mass into acceleration. First, initially we will write the force for the mass element, that is Fm is equals to, we know that it is m into acceleration. M, capital M is the mass, d square x by dt square for mass element. And for damper element we write F into velocity. Velocity is nothing but what? Dx by dt, the differentiation of displacement by time. And for the spring circuit we write K into x. Why? Because K is the element notation, K into x is the displacement. So separately we will write the force for the free body diagram, from the free body diagram. After that the total will become the addition of these all three. Write md square x by dt square plus f into dx by dt plus kx. After writing this, you can write this in terms of velocity also. So f total will become, as you know that V is equals to dx by dt, right? You know that V is equals to dx by dt. If you substitute in this place V place dx by dt, again you will get d square x by dt square only. So in the place of dx by dt we are substituting V here, that's it, dv by dt, and here dx by dt is what, fv, and you know that V is equals to dx by dt. If differentiation goes on the left side, it becomes integration integral V is equals to x. So in the place of x we can write integral V dt. So taking now we need to take the Laplace transform, as we took in the deriving the equations in the previous theory also. We have took the Laplace transform. Same here also, after writing the equation we'll take the Laplace transform. Laplace transform taking here is easy, no need to remember any formulas. Just Laplace transform, how f total will become of f of s. In terms of s you are going to write m into, you know that differentiation, double differentiation Laplace transform is s square into x of s. We have proved that in the previous module. Module 2 second part, we have learned Laplace transform. In Laplace transform, here Laplace transform of d square x by dt square will become what? S square into x of s. Okay, and Laplace transform of dx by dt, m into, you'll write s square x of s, and Laplace transform of dx by dt is s into x of s. Differentiation theorem what we have studied in the module 2. If you have not seen yet module 2, please check out, but you can remember just like this, that differentiation, double differentiation Laplace transform is s square into x of s, and just differentiation dx by dt is s into x of s, and x is nothing but x of s itself, k into x of s. After writing this, you want a transfer function. Transfer function means what? Output by input. Input is what? Force what we are applying. Output is what? The displacement, it will move. See, you are applying some force to some element. What it happens? It is going to move to some place, right? So input will become the force, and the output will become what? The displacement it moved, or the distance it moved. So output is what? The x of s. Input is what? F of s. So if you take the common from this x of s, what will you will get? M square plus f plus k, right? So if you want x of s by f of s, so this ms square plus fs plus k will come to denominator. So this is what the transfer function. So first question what we want is clear now. Transfer function we got. Now we need to obtain the analogous electrical network based on force voltage and force current analogy. You know that force current analogy, in the previous video itself there is a table where how to compare the translational systems with the electrical system, how to notation just difference, but they are analogous systems. The equations are similar. See, in analogy, force current analogy, what we do is, you need to consider the main equation what you got. For that main equation, in force current analogy, the F will become the I, and M will become the C, and d square x by dt square will become the d square phi by dt square, and dx by dt will become d phi by dt, and F becomes the 1 by R, and the K spring element will become the 1 by L, that is inductance. So we can convert this phi into voltage also. I is equals to C into dE by dt, the plus 1 by R into d phi by dt is E, and plus 1 by L into integral E dt. How we are writing this is same. How means, you know that E is equals to d phi by dt. Electricity voltage is nothing but rate of change of flux. Okay. So if you take this differentiation on the left side, phi will become integral E dt, and d phi by dt is what? You can substitute voltage, that is E. And d square phi by dt square, what happens? We will write the one of the d phi by dt as E. So it will become d by dt of E. Understanding? So till now here we are done with force current analogy. For this you need to remember the table what I have mentioned in the previous video, that how to convert M into what we need to convert for force current analogy, for F what we need to convert, for K what we need to convert, and for X what we need to write. Understanding? From this we need to draw the analogous electrical circuit. How to write? I'll tell that. It is force current analogy. We know that current source will be always in parallel with the circuit's elements, right? Whether capacitor, resistor or inductor. So in the same way, I is equals to F, you will write C equals to M, R is equals to 1 by F, L is equals to 1 by K, and in the parallel form you will connect in this way with the grounded. Understanding simple, only this much. For force voltage analogy, how to draw? Here force voltage analogy, again for the main equation, what you are going to do? You are going to convert this F will become what? Voltage. Why? Because it is force voltage analogy, and M will become what? L, inductance here, and F will become R, and K will become 1 by C, and here X will become Q, charge, dq by dt, voltage no, so dq by dt it will become X. So in again this we can write as, you know that I is equals to Q by T. I'm sorry, the equation is wrong. In place of d square Q by dt square, what we are substituting? Di by dq by dt is nothing but what? I. So in place of I, if you substitute dq by dt, it will become d square Q by dt square. Nothing but what? I is equals to Q by T. Understanding? I is equals to Q by T. So in place of I, you can write Q by T. Understanding? So in place of Q, what you can write then? In place of Q, you can write I into dt. Okay. In place of Q, you can write I into dt. So in this way, we can convert the equations. In place of Q, in terms of I, you can write. Why? Because you know that V equals to current I into R. I into R. I into R. Again here you see, I is equals to V by R. V by R. V by R. See, all those are nothing but the passive components. So you know that V equals to IR. The equation should be in that way. You can keep that in mind. Like you can you can analyze things whether you are correct or no. See, V should be equals to IR. You see, this is a type of R. L into di by dt. R into I. 1 by C into in terms of I. I will be in terms of V into R. Sorry, V by R. V by R. Like this you can remember. But you need to remember where the 1 by L need to be taken, where 1 by C need to be taken. Here you should see M is represented as L here. Here C. Here F is represented 1 by R. But here F is represented as R. Here K is represented as 1 by L. But here K is represented as 1 by C. So you need to see you need to remember or memorize the table. So it will be easy for you. The previous video, what table I have given, no? In that you need to remember that table to solve these sums, and you should know how to take the equation, the free body diagram, and from that Laplace transform. Okay. Next question is, write the differential equations for the mechanical system shown in figure. This is the mechanical system. Same like previous problem, we should convert this diagram into the free body diagram. Here what I did is, here it is in the form of vertical, no? I just tilted and taken in terms of horizontal the free body diagram. How to write free body diagram? First you write first there is the M1. First you write the M mass element, so that you can connect the forces connecting to the mass element. So first one we have force F1, which is here F1. Then which are the other K1 and F1. K1 is with respect to X1, so K1 X1 in the opposite direction. Again in the opposite direction F1, that is the dashpot circuit, with F1 into, there are two displacements, so it is X1 minus X2. Then next you will connect M2 as it is connected to M2. Next here M2 is connected. For M2 you will connect K2. K2 in opposite direction, that is K2 into X2. Anyway F1 is already connected between both, and F2 is connected in this way. Why? Because there is another force F2 here. So which all are there you need to connect, and displacement also you need to mention. If you see, there is a displacement between this and 2, that is X1 and X2, and we will consider even the velocity. The differential equations, how we will write? Here we need to write two differential equations for m1, for m2 separately. m2, first we'll write for m2. m2 into d square x2 by dt square. Why? Because it is with respect to x2, displacement is with respect to x2, plus f1 into with respect to x2, no. So first you should take x2 term. So f1 into dx2 by dt minus dx1 by dt plus k2 into x2 is equals to f2 of t. Why? Because the force is applied to mass element is f2 of t. As it is in between both m1 and m2, this also you will consider. This you will consider for both m1 and m2 also. So from displacement we can convert into velocity terms also. How? m2 into dv2 by dt plus f1 into v2 minus v1 plus k2 into integral v2 dt, that is equals to f2 of t. So we can convert x displacement into voltage in this time, in this way. After this, now we will write the equation for mass element m1. Same like this, m1 into d square x1 by dt square plus f1 into, as it is with respect to x1, first you will write with x1 dx1 by dt minus dx2 by dt. After that plus k1 into x1. Next is the spring element we have, that is k1 into x1. Write that is equals to, what is the force applied? f1 of t. Then in terms of velocity, how we will convert? m1 into dv1 by dt plus f1 into v1 minus v2 plus k1 into integral v1 dt, that is equals to f1 of t. So here they just asked the differential equation. So we have found the differential equations. Understanding? If in case, if they asked f2, transfer function of f2 by x1 or f2 by x2, you can find from this, taking common or substituting, you can find. Like this kind of sums of transfer function also I will do in further slides. For till here, here they just ask for the differential equation. Next, just we need to write differential equation. Next question, find the transfer function x0 of s by xi of s. What is x0 here? This is x0, this is xi of s. x0 of s and xi of s, they are asking for the system shown in figure. First what we should do, first we will write the free body diagram. You can see mass element is present, mass element is in the same way, and other elements are, there is no force applied here. So no force element we are going to take here. Understanding? But the spring is there. Spring is of k into, as there are two displacements, we will consider x0 minus xi, and here also for dashpot circuit also f of x0 minus xi will consider. Understanding? Now if you see here x0 dot they are mentioning, if you see that x0 dot, that means that it is differentiation. Understanding? We write dash, no, we can even write dash, x0 dash. For differentiation we can mention in this way also, xi dash, nothing but it is differentiation. So keep that in mind. I think I didn't mention this, or else if you can simply write f of dx0 by dt minus dxi by dt also. Okay, in this way also, in this way also you can represent. After writing, what we will do? We will write a differential equation. Same. How we will write differential equation? What are the forces applied to that mass element? First one is m into d square x naught by dt square with respect to my, because the displacement with respect to m is x0. So x0 only will consider. Understanding? Then f into dx0 minus dxi by dt plus k into x0 minus xi, that is equals to 0. F into dx0 for this and x into k into x naught minus xi equals to 0. Why 0? There is no force applied. They have not given any f. See, for example, here f is given, then or here f is given. Then we need to consider, as there is no force applied, force given, it will be 0. We will consider it as 0. Now what we should do? We should take the Laplace transform. How we will take m into d square x0 by dt square. If it is in the double differentiation, we will write s square into x0 of s. Then dx0 by dt and dxi by dt, what will become x0 of s, xi of s. then k into x naught of s minus xi of s. Here we will write s into x naught of s. Here s is taken common, keep that in mind. Here directly we write x naught into s, xi of s, but here it is differentiation, so it is s into x naught of s, x into xi of s. So we are taking s common. Then what you will do? You will take x naught of s as the common. Why? Because we want x naught of s by xi of s. If you take x naught of s common in this, you will get ms square in this and fs here and a k into x naught of s. If you want x1 of s, we'll send this x1 of s into the right side. Then you will get fs plus fs plus k into xi of s. The transfer function what you want, x naught by xi of s. So what it will become, fs by k, fs plus k by ms square plus fs plus k. That is what we want, transfer function. So we found the transfer function. Understanding? We need to write the free body diagram, write the equations, then do the Laplace transform for finding the transfer function. Or else if we just ask the differential equation, if you write till here it is enough. Or if they ask for Laplace transform till here it is enough. But if they ask for transfer function, you need to do this. For differential equation this, for Laplace transform this, and for transfer function this. If the transfer function is asked, first you should write differential equation, then do Laplace transform, then the transfer function, you will, whichever transfer function they ask, you can do. But initially you should draw the free body diagram so that it will be easy for you to analyze and do the equation. Free body diagram is compulsory. The next question, consider the mechanical system shown in figure. Suppose that the system is set into motion by unit impulse force. Find the resultant oscillation, assuming that the system is at rest initially. What they are asking, mechanical system is given. Suppose the system is set into motion. If it is set into motion by impulse force, they are asking for oscillation, resulting oscillation. Then assume that the system is at rest initially. Initially it is in rest, then it will, then a little bit of motion or the force is applied. We need to find the resulting oscillation. How we will see. Same, the procedure is same, but a little bit ending we need to understand. Here first initially you will write the mass element. Then for that the applied force is what? Impulse force they told. So delta. So delta of t. Then x is the displacement. We will consider even the velocity. Then one more is the spring element. So spring element will be in the opposite, that is kx. After writing this, what we should do? We will write the differential equation. What is the differential equation? Force here is delta of t, that is equals to kx plus m into d square x by dt square. Okay, there is no damper element here, so we are not going damper or the what is that dashpot element which is in this form. No, this kind of element is not there, so no need to write that. Whichever elements are connected to that mass element, no, only that need to be written in the equation. After writing, taking the Laplace transform on both sides. What is the Laplace transform of delta of t? If you have seen my videos in Laplace transform in the module 2, then you will understand. But Laplace transform of, just remember, Laplace transform of delta of t, impulse function is 1. Laplace transform of delta of t is 1. And k into x of s, m into s square into x of s. So ms square plus k into x of s will take as common. Then x of s is equal to what? 1 by ms square plus k. That is equals to, if you take m common here, s square minus k by n. Not minus, here it is plus. S square plus k by m, that is equals to 1 by m into, what they have done here is, here if you see, s square 1 by m into s square plus k by m. Here m is multiplied. See how it is done is s square m plus k by m. Okay. If you solve this, again you get this only. I will show you how. See, root of k by m. Okay, anyway, we'll do one thing. See here, easily I'll explain. Don't want calculation here. See, just what they have done here is this k by m is there, no? They have took square root k by m and whole square. If you see here, if you take whole square, this square and this square root get cancelled, no? Nothing but again you'll get k by m, right? So that is the reason why they have took square root of whole square, and what they did, root k by m multiplied and divided. So anyway, if you cancel this and you cancel the square root and square root, again you will get k by m only. So why they have took in that way is because they are asking for the finding the resultant oscillation. To find the resultant oscillation, we want this equation in this way. Understanding, resulting oscillation frequency is nothing but omega. If you want omega, so it should be in terms of omega terms, no? Omega terms when you will get in terms of in Laplace transform, what is there? If you don't know Laplace transform, please do watch my video which is in module 2, final part. Laplace transform I have done. The Laplace transform of sin omega t is, sin omega is omega by s square plus omega square. Okay, now. So you should know this. By from that only we are finding this omega. So in that terms they are converting 1 by m into s square plus k by m, 1 by m into they have what they have took root k by m can get cancelled, so only they have took multiplied and divided, and they have to make this also as omega, they made root of k by m whole square, nothing but again you will get k by m only, nothing but here it is in the form of this root k by m is nothing but omega. Okay, keep that in mind. So that into 1 by root k by m, taking the inverse Laplace transform. If you take inverse Laplace transform for this, what you will get, x of t is equals to 1 by root mk. If you solve this too, you will get 1 by root mk. This is nothing but Laplace inverse of this is nothing but sin omega t. As I told, Laplace transform of sin omega t is omega by s square plus omega square. Here omega is root k by m. But inverse Laplace transform of omega by s square plus omega square is omega by s square plus omega square is what? Sin omega t. So omega is root k by m. So omega is what? Root k by m radians per second. Omega units is radians per second. This is what they wanted. Resulting oscillation frequency. So for that sake we are converting in this way. So keep this in mind. They may ask in this way also. So you should know Laplace transform first. Understanding? If you don't know this formula, for now anyway I have explained for you. But if you don't know, if you want Laplace transform in still more depth, you can see my module 2 video. Assume that the cart in the figure is standing still for t less than 0. U of t is the displacement of the cart and y of t is the output. Y of t is the output they are telling. U of t is the displacement. Understanding? So, displacement and y is the output. Obtain the transfer function of the system. Here the same, you just don't get confused with these all things. What we want, those elements and the directions of they are moving. What we should consider, mass element. Mass element, does it have any force? No. So we have the elements, that is spring element k, and the displacement what they are telling you. So what we should do, k into y minus u. You may need to write. Why? Because the displacement here is u. We need to consider what they have given, displacement and u, y is output. So if you consider here, u will be the displacement. So f k of y minus u and f of y dash minus u dash. Y dash minus u dash. K and f. Y dash minus u dash. So y dash is nothing but what? Dy by dt, du by dt. Understanding? After writing free body diagram, we will write the differential equation same way. M into d square, it is with respect to y. So d square y by dt square, and f into dy by dt minus du by dt. Understanding? Plus k into y minus u equals to 0, as there is no force 0. Taking Laplace transform, again you will get m into s square into y of s minus plus fs into ys minus u of s plus k into y of s minus u of s, that is equals to 0. Again if you take y of s common, you will get ms square plus fs plus k, and u of s common, fs plus k. Therefore transfer function we want here, transfer function is nothing but output by input. Output is what? Y of s. They have given output as y of s. So y of s by u of s you will get as fs plus k by ms square plus fs plus k. So simple, no? Just we should write the what? The free body diagram, write the equations based on the free body diagram and find the transfer function. Next question, write the differential equations for the mechanical system shown in figure. Obtain the analogous electrical networks based on force current and force voltage analogy. Okay, they are asking for the differential equation and obtain the electrical network, analogous electrical network, force current and force voltage analogy. What the same way we have done for the first problem. If you see here, there is a mass element first draw of the mass element. After drawing mass element, what are the forces applied on it? If you see f of t is applied, so f of t, and y is given here, so y by 1 and v1 will be the velocity, and there is a spring element between the reference point and this, so this will be ky2, as it is spring element ky2, and between the spring element and this mass element there is a dashpot. So f2 into y1 minus y2, y1 dash minus y2 dash, nothing but dy1 by dt minus dy2 by dt. As f2 is between y1 and y2, we are taking f2 of y1 dash minus y2 dash. Okay, this is spring, this is dashpot, this is mass element. So we have written everything. And one more thing you need to observe here is very important. Across the mass element, there may be no dashpot diagram like this given, but they have mentioned F1. So there is some F1 force, some dashpot force of F1 in that mass element present. So we need to consider that also as F1 by 1. Keep that in mind. If that is not given under the mass element, okay, fine. If F1 or K also if it is given, then you will take as KY1. But here they have given F1. So F1 by 1 dash we need to consider. Remember that. F1 by 1 dash or F1 dy1 by dt. Okay. Again I am repeating once again. This is very important. These all things you will write KY2. F2 into y1 minus y2, y because it is between y2 and y1, and mass element there is a force y1 v1, and you will forget this. This is also important. Why? Because under mass element, till now this type of question has not come. Under the mass element there is F1 present. So there is some damp dashpot element present in mass element. So you need to consider that also as F1 by 1, even though it is not given in this way. This like element, if mass is given with down as F1, so you need to mention that force also for that mass element. Keep that in mind. I am repeating twice because it is very important. So differential equations describing the behavior of given mechanical system are, we write the differential equations. F of t is equals to, there is force, so f of t is equals to m into d square by 1 by dt square plus f1 into dy1 by dt plus f2 into d into y1 by dt minus d into y2 by dt. So first we will write only this much. Okay, why? Because this is one of the circuit we are getting. Why? For this mass element only this much is connected. This much is connected. The other one will write the separate equation. How? As there is no force present for this spring element or this, so what we will do? We will put a 0. Then what is the next equation? F2 into, here we are writing with respect to y2 displacement. So it will be dy2 first and dy1. Here dy1 first. Why? Because we are writing with respect to y1. But here we are writing with respect to y2. So dy2 by dt minus dy1 by dt plus ky2 that is equals to, you will get 0 is equals to F2 into, we can write in terms of, here also we have written in terms of velocity, v1 by dt, F1 into v1 plus F2 into v1 minus v2. In the same way, F2 into v2 minus v1 plus k into integral v2 dt, integral minus infinity to t, v2 dt. So like this, you need to write the differential equations. But keep this in mind, don't forget how to consider this. You need to consider that element also. If that is not considered, your equation will be wrong. Then after completing that, what they have asked? They asked for force current analogy and force voltage analogy. Already you got the main equations, two main equations. Those two main equations you need to convert into respect to current analogy and force voltage analogy. Current analogy is what? First you write I of t, force in terms of I of t. Then M is C and F is 1 by R1 and F2 is 1 by R2. And for the next equation, F2 is 1 by R2 and 1 by L is what? This spring element is 1 by L. Okay, now. So for this, how to draw the diagram? See carefully, as it is current force current analogy. First, the force is applied which side? Right side. So first you write off the current element first. I of t is equals to F. Why? Because we are considering F of t is the I of t in electrical system. Then parallel, M is C. So you will consider parallelly C. C equals to M. Then again you have parallelly what? F1. Why parallelly F1? Why? Because M has F1 present also. In this diagram also you need to consider F1. After that, if you see, R2 is equals to 1 by F2 is given. You can write F2 is equals to 1 by R2 or R2 is equals to 1 by F2. Anything is fine. This F2 is between this and this. Here also in diagram also if you check, it is between what? F2 is between this K element and this F1 element. Okay. This F1 element and K element. This is mass block. These two are in parallel. In between there is F2. So you consider F2 as resistance here. Then the inductor. Inductor like this parallelly again. If you want, once again I'll explain. It will be easy so that any of the sum you can solve. Why? Because this same questions will be not repeated in the exam. Why? Because they can give any of the questions. So you should know the concept behind it. First understand. First you have written the main equation. From the main equation you have converted into electrical equations like F is as I, M as C and then a dashpot, that is F as 1 by R1, F2 as 1 by R2. Right. Then from that what you have done? Again E2 minus E1 by R2, F2 as R, 1 by R and the spring element as 1 by L. Understanding? So in this way you have converted. After converting it, here you can write in terms of phi also. If you want d square phi by dt square also you can write in terms of, directly I have took the, here directly what they have done is they have took the voltage equation. If you want, first you can write d square phi by dt square and then convert to this. But anyway you can write directly also. In this way, after writing this, what we should do? First you should write the current element which is present, that is F of t, which is right side. I of t is equals to F of t. You have mass element, you will write off that as capacitor. And again you have the F1 connected to M. So you will write that also as resistance. Then F2 is in between this and this. So you will mention it between this and this. And the inductor connected again parallel to the mass element and series with this. So understanding, you need to draw the diagram also. So I am stressing so much. Then the next equation. What we are writing? First we have written for force current analogy. Now next is force voltage. As you know, force voltage is nothing but in terms of E, that is voltage terms. Voltage is equals to M becomes L and F becomes R1, F2 becomes R2. F2 becomes R2. Here again this spring becomes 1 by C. Keep that in mind. After writing these two equations from the main equation, then what we will do? As the voltage is in series with the components, first you write the voltage component as E of t is equals to F of t. Then in series you have what? Inductor as M here. So M again in series with F1, R1. Then F2 is in between K and M. So you will connect it in between this and this, and K, 1 by K as C. So capacitor. Between this and this you are mentioning F2. As in diagram it is in that way. Force voltage analogy need to be drawn in this way only, and force current analogy need to be drawn in this way only. In force current analogy, current will be in parallel with the resistances, and if any middle term it will be connecting in series. But in force voltage analogy, the voltage will be connected in series with all the elements, but the between, if anything is present between any two, that will be connected in parallel. Keep that in mind. Understanding? After writing the equations, you need to draw the circuits also. So only I am stressing so much. Practice them, you will understand. You write and practice, then only you will understand. Next, this question is from your previous question paper. So try to understand. It's very easy. Write the differential equations for the mechanical system shown in figure, and also electrical analogous circuit based on only force voltage analogy they are asked. How to write? Here first you will write a free body diagram. How we will write? First M1, and for M1 what all are connected? This B1, as I told, this dashpot they may give F1 or B1 according to the question. You need to change the notation. See, B1 is between M1 and M2, so I have taken between two arrows and took FB1 into X2 dash and X3 dash. Understanding? X2 dash and X3 dash. Here I forgot to write the differential dash, so I am mentioning it now. The dash represents the differentiation, dx2 by dt and dx3 by dt. Okay, and M1 which is connected with x2 of t, so this is the displacement x2 of t, and another element is connected here is fk1, f into k1, f of t. Here x1 of t displacement. Same like diagram, only it will be looking same like figure, just to understand. And fk1 into x2 minus x1, f of force of this k1 into this x2 minus x1. Then the force, one more force is what? F of that force M1 itself. If you want, you can mention this, or else don't want. Till now we have not mentioned, otherwise don't want. Fm1 is nothing but this. No need to mention. Just to understand I have mentioned, because the force of the mass element also need to be considered. Now we are done with M1. For M2 what we will do? X3 of t is given in the question. Then anyway B1 is written. After writing B1, what we will write? There is a spring connected, so FK2 into X3 and FB2 into X3 dash. B2 into X3 dash. I actually forgot writing some things. Directly I have written. No, actually what I have considered here is forces. I didn't mention. See, if we are considering in B2 into X3 dash, then directly we can write. But I have took here FB2, FK2. So it's okay. Like this also you can write. No problem. No worries. See, FK2 is the notation, and FK2 will become what? K2 into X3. Understanding? Either you can write FK2 or K2 X3. It's your wish. Understanding? Which follow any one thing. Here FK2 or you write, or X2 K2 X3. Here FB2, or you can write FB2, or you can write that is equals to what? V2 into dx3 by dt. dx3 by d3. Understanding? You can write in that way also. After writing, what we'll do? We'll write the differential equation. Fm, first we'll write for m1. For m1 and m2 separately we should write. So m1, first m1, fm1 is equals to what? m1 into dx square by dx2 square by dt square plus b1 into, with respect to x2, no, so dx2 by dt minus dx3 by dt. Okay, b1 is between x2 and x3 and k1 is between x2 with respect to x2, so we write first x2 minus x1. And f1 in terms of velocity also you can write. I am not repeating how to write velocity. Anyway, I have told previous sums also. Just convert to velocity. Then fm2, m2 into d square x3 by dt square. Why? Because with respect to d3. And b2 into dx3 by dt plus b1 into, with respect to x3, no, so x3 first you should write dx3 by dt minus dx2 by dt. Then k2 into, with respect to x3. Again you can convert into what? Velocity. After that, what they are asking for force voltage analogy. Force voltage analogy, what we will do? We have two equations we got here for fm1 and for fm2. This equation and that both equation need to be converted into the force voltage analogy in the electrical system. First, in force voltage analogy, left hand side fm will become what? E. E is equals to, m will become L1, m1 will become L1 and v1 will become R1 and k1 will become 1 by c1. We can write in terms of charge initially, d square q2 by dt square, dq2 by dt and minus dq3 by dt and q2 minus q1. This can be converted into I terms, that is E is equals to L1 into di2 by dt plus R1 into I2 by I3, I2 minus I3, 1 by c1 integral I2 minus I1 by I2 minus I1 into dt. Either you can write directly the I2 form, I2 and the voltage form, or you can write first charge form. Either you can write first charge form, then you can mention the current form. See, first you can write in terms of charge and write again in terms of current. Anyways is fine. Okay. Then after this, for the second equation also we will write the analogous electrical system circuit current equation. Here what we will do, fm2 is 0. Why? There is no force. Here for the first m1 block there is force f of t mentioned, but m2 there is no force mentioned. So you will take 0. 0 is equals to, same in this way only you will write L2, R2, R1 and 1 by C2. Then then what you have, you can convert into I terms. R2 L2 into di3 by dt plus R2 into I3 plus R1 into I3 minus I2 plus 1 by C2 into integral I3 dt. You can convert in this way. Force voltage analogy, what is the rule to draw the circuit? First we should draw the voltage source which is present right side here. So we will take right side, plus minus E is equals to f of t. E will become f of t, the total force f of t. Then for voltage the elements should be in series. So first element which is what is there, m1 is there. So m is equals to L1, m1 equals to L1. Then you have the capacitor. Why? Because this m1 is connected with what? The K1 is nothing but here the capacitor 1 by C1 or 1 by C1 is equal to K1 or 1 by K1 is equal to C1, you can mention. Then later if you see this V1 here is resistance, V1 is R. So V1 need to be in between this M2 and M1. So this M2 is here, M1 is here, between M2 and M1 R1 is there. After then you need to mention the M2, the next circuit M2, next circuit M2. After writing M2 is equals to L2, these two are in what? In series again. Again you will mention in series what the capacitor and the resistance. Just you should know the notation. In that way only you need to write the circuit as well as the conversion of the 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 differential equation in the translation system to the electrical system. This is the translational, this is the electrical system equation. After that you need to draw the circuit diagram. Keep that in mind. Then write the differential equations governing the behavior of the mechanical translational system. See, by seeing this you will feel so tough, but it is very easy, right? If you know the concept. How you will write? You will write M1, M2, M3. Here they have given F1, F2, two forces, F1 of t, F2 of t. Then with this what is connected? K1 into X1. Here if you see, every time the force, if it is in this direction, the other elements will be in the opposite direction. It will not move in the same direction. No, if you are applying force in one direction, it is going to move in the opposite direction. So F1 of t, K1 X1 you will write in there, and next one you have dash. What connected to it? That is F1. That is F1 X1 dash you can write. Okay, F1 X1 dash or F1 dx1 by dt. Then again between M2 and M1 what is there? K2 is there. So K2 into, with respect to what, with it has K1 X1 also X2 also. So you write X1 minus X2. Only that is element is there. Then M2 and M3 what two elements are there? K3. So K3 is equals to, it is between K2 and X2 and X3. So you will write X2 minus X3. Then F3 is also present in between M2 and M3. You will write F3 into dx2 by dt minus dx3 by dt, or F3 is equals to x2 dash minus x3 dash. X3 dash. After that you will mention this, these displacements also need to be mentioned. After writing the free body diagram from the main diagram, you will write the differential equation. What you will do? Separately you are going to write for F1 of t, F2 of t, and the last equation. Nothing but M1, M2, M3. For the M1, F1 of t is equals to M1 d square x1 plus M1 into dx1 by dt plus K1 into x1 plus K2 into x1 into x1 minus x2. Why? Because with respect to x1 we are writing, first we should write x1. You can convert this into velocity also. In the same way you will write for F2 of t. As there is no F3 of t force here, you will put 0 and write the equation. Understanding? I am not telling in depth because till now I have explained all the problems in depth how to write the equation. Same way you know going to write the equations for this also. So these are the practice questions. You please practice. If you have any doubt, you can comment me in the comment box which is present. So I will help you out. If you have any doubt with this practice questions or any of the doubts within the video, I will explain. By now I'll stop the video here. What we have seen here, mechanical translational system. Now in the next video I will do mechanical rotational system. So after this analogous system, I started with the problems, right? This is the first video, mechanical translational, and the next video will be mechanical rotational system. Thank you. From Sri Sai Tech Edu YouTube channel, Read, Lead, Success. Keep reading.